Hello everyone. Okay, so I want to start with this. This is a presentation for my capstone. So hopefully, uh, try to give you a bigger or a basic picture of how the machine learning algorithm works. Okay, so starting with the uh, I'll start with the standard machine learning pipeline. Okay, give me a second. Okay, so usually we have the data preparation. So you're getting data from like offline data or online data. So in the format of CSV, XML, or JSON. It could be images, text, or numbers, so etc. And then you prepare the data, and then after you get the data, you have to extract the features, right? You want to use it for the model. So the features, so you could do like stratification or normalization. You detect any outliers, missing values. If there's missing value, you change it to either like 0 or find the average. And then when the features are ready, then so usually after that you will have a train, test, and a valid set, right? So the train set is the highest volume of the data. You use it for the model training, and then you use after the trained, then you use the validation set to check the accuracy and find any or to find the optimal hyperparameter, and then you test it on the test data. So basically the test data is kind of like unseen data for the model trained. So you want to see how good it performs before you deploy the model into the real life. So when you have the model prepared, then you use it to predict unseen data in a real life scenario. So in the next, so we have types of machine learning. So basically the most frequently used are supervised and unsupervised. So supervised is the labeled data, and the unsupervised is the unlabeled data. Supervised is the labeled data are usually really expensive, so you have to, if there's no label, you might have to spend a lot of time and money to uh, label the data. Unsupervised pretty cheap. So semi-supervised is basically both supervised and unsupervised, but there's a more unsupervised, unlabeled data. And reinforcement is a kind of a machine learning types where uh, it gets rewarded based on the actions. So if it performs the right action, it gets rewarded, something like that. So the next, so basically I work on the three algorithms, but still need to work on it. So the first is KNN, then K nearest neighbor, which is supervised, decision tree, supervised, and the K means unsupervised. So basically these three are used for the predicting classification or the category, whether it belongs to this class or the class. And there is you could use this algorithm, the k-nearest and decision, also to predict the regression, which is to find the real number. So the project plan is to research on the algorithms, how exactly it works, what's the math behind it, and try to build it from scratch using Python with the minimum use of libraries. So you could also use build it without using pandas and numpy, but I try to use the numpy and pandas libraries as well. But you're not allowed to use the scikit-learn, so which is the if you don't want to build it from scratch, you usually use the scikit-learn. It contains all the machine learning algorithms. And then to build it, you need a dataset, right? So the dataset we're using is from the UCI machine learning repository. And when you build model, you have to test it, right? So we usually test and evaluate the algorithms. The real concepts, so the basic foundation concepts are like underfitting and the overfit. So underfit is if it's like doesn't create the good, let's say, decision boundaries. So when you predict in a new unseen data, it won't predict well, right? Uh, it there's a high chances of misclassification, and then good fit is exactly the decision boundary is perfect, kind of. So and overfit is like it's too perfect, so you don't want to have that too, because the real life scenario, the unseen data, you don't know how it is. So if it's too perfect, there's a high chances of mistake. That's as far as I know. I need to work. I need to have 100% work on it. So bias and variance. So it's also related to the underfit and overfit. So it's a low bias if it predicts well on trained data. So usually you first train the data on the trained data, right? So it predicts well on the trained data, but okay, that's a low bias. But otherwise, if it doesn't predict well on the trained data, there is a high bias or a model underfits. So it overfits when predicts well on trained data, but it doesn't predicts well on the tests and the valid data. And the variance is the measures of specificity of the match. So high variance means like it's a weak match, so too sensitive to outliers. It basically like overfits. It basically overfits, yeah. And other concept is the normalization. So you usually want to convert the data into like standard range, like -1 to 1 or 0 to 1. So you could use the concept of the mean max. And these are the three sets. Usually you want to have the largest volume of train sets. So usually like you could say 70% or 80%. Valid set is, or you could, if you have a train set 80%, you could have a 10% valid and 10% test set. If it's 70, you could do like, so it depends. So usually valid set is to find the best hyperparameter, and test set is to access the model before deploying into the production. Okay, so usually these are the performance metrics. So confusion metrics is to compare the how well it performed, like actual versus the predicted. Because you already know, you already have the data and the label, so and then you can check like what's the prediction and then compare it. And accuracy is the correctly classified divided by the total number of classified examples. So this is the good chart. So you usually have a predicted. So usually it's, let's say you have two labels, like I don't know, no negative and positive, and then like true labels and predicted labels. So there is like concept of true negative, false positive, false negative, true positive. Okay, so the data set we use is breast cancer and the monk's problem from the UCI machine learning. So yeah, so breast cancer data set is basically trying to see if it's a benign or malignant cancer. So benign, I think it was like 2, and malignant is 4. So it's basically binary classification or binomial classification. So we're using the KNN and K-means to so KNN and K-means is using this data set. Monk's problem is basically checking which of the 3 problems. So there is like Monk 1, Monk 2, Monk 2. So let's say there's 3 problems. So which of these problems is most difficult for the algorithm we built to learn? So it's also a binary classification problem. So the class could be 0 or 1. And yeah, the algorithm we're using is a decision tree. And I had a hard time understanding the algorithm, the attribute description of the Monk's dataset, but so I see this example. So you could say, suppose there is an artificial robot, right? So the domain is described by 6 attributes. So there is a 6 attributes A1 to A6. So A1 represent head shape, so the shape of the head. So if it's round, it's 1. So there's a A1 could be either 1, 2, or 3. So if it's 1, it means the head shape is round. Square is, yeah, 2 is for square. Octagon is for 3. So same goes with A2 is for body shape. It could be 1, 2, 3. A3 is like whether it's smiling, yes or no. One, so it could be 1 or 2. Holding, jacket collar, and hairstyles. Okay, I'm going to continue about the other 3 algorithms next part.